Hello students, welcome to the next session on a discussion of water turbines. So in today's class, we will be discussing regarding water turbines, how do they work, their classification and as well as their applications. First of all, water turbines. In simple words, turbine is nothing but a device which can generate power, or you can say it is a power producing machine or a power generating machine also. Basically, there are three types of turbines which we are using in our daily life, and these we are classifying them based upon the type of fluid flowing in those turbines. One is a water turbine, another one is a steam turbine, and the third one which you are observing here is a gas turbine. As I was telling you, we are classifying them depending upon the fluid used. Water turbines, which means we are using water as the worked fluid in these turbines, and generally we are using these turbines in power plants, that is the dams and small dams. If we are using steam as a working fluid, then we call those turbines as steam turbines. Already regarding this we have discussed in the boiler section, where we have told that within the boiler the steam is developed, that is the dry steam or superheated steam, which is used in the steam turbines. Here we are using that steam turbines to develop the energy, and these steam turbines especially we are installing them in steam power plants. The nearest one is here, we are having NTPC at Kudgi power plant, which is taking help of this the steam turbines itself. And the third category is using of the gases. We may use air as a gas or any other gases to run the turbines. We call them as gas turbines. So the example for this gas turbines, generally we are using them in rockets, windmills, everywhere we are using this. Especially for the rockets, we are using the gas turbines itself. Even the aeroplanes which we are running, they are all running in the form of using the gas turbines itself. Now, for our syllabus, we are having regarding the discussion of water turbines. We shall go further in detail regarding the water turbines. So already you have seen this picture in your previous days also, right? From our olden days, our ancestors were using this type of device for supplying the water to the fields. So in simple, it is nothing but a water turbine itself. How it is operating? See here, just here in simple words, we have defined this as an hydraulic prime mover. That is a prime mover device which converts the energy of falling water. So energy of falling water into mechanical energy, or you can say that which converts the kinetic energy of the falling water into mechanical energy. Here you can see there is a shaft on which these blades are being mounted. So this shaft, when it rotates, it develops energy, and that energy is nothing but in the form of an useful energy for the various applications. So a water turbine is an hydraulic prime mover which converts the kinetic energy into mechanical energy by the rotation of a shaft itself. In the water turbines, we are again classifying it based upon different categories. One of it is regarding depending upon the energy available at the turbine. Second one is the head available, and the third one is direction of water flow. What is this first classification factor? Energy available. So sometimes for some turbines, the energy available at that point of impact is high. We call it as an impulse turbine, where almost all the kinetic energy, is used in generating into useful work or the mechanical energy. We call that where the entire kinetic energy is completely converted to mechanical energy. We call that turbine as impulse turbine. Whereas there are some other turbines where along with kinetic energy, that is part of kinetic energy and a part of pressure energy is used to develop useful mechanical work. We call those turbines as reaction turbines. It is nothing but generally it is based mainly on the Newton's third law of motion, which you have already learned that for every action there is equal and opposite reaction taking place. The same happens here also. So even in this reaction turbine, there is part of kinetic energy acting, which is in the form of an action. And due to that action, there is some amount of pressure energy developed. That is due to the reaction developed. We call it as both impulse and reaction together, known as reaction turbine. This is the first factor of classification, that is depending upon the energy available. Second factor is the head available. Head in the sense height of water available for the water turbines. So almost we know that on the earth, everywhere we don't find the same height of the water to be stored. In some places, the water is stored at a height more than 300 meters. Some places in the range of 50 meters to 150 meters, and some places lesser than even 50 meters also. So depending upon the height of water available, we are classifying, sub-classifying them as the three categories. So we call it as the head available. So high head in the sense where the water level is stored at a range more than 300 meters. Medium head for a head in the range of 50 meters to 150 meters, and low head for height less than 50 meters. Then the third category is regarding the direction of flow of water. What does this mean is when the water is taken from the dams, it is taken through certain pipes and then it is being struck on the turbine blades. So in some cases, when the water is being struck, it takes some amount of time to impinge with the blades. It may be in the form of a tangential flow, in the form of an axial flow, in the form of an radial flow, in the form of an mixed flow. So the three turbines which you are going to learn, that is the Pelton Wheel turbine, Francis turbine, and Kaplan turbine, they are all categorized using these factors itself, which we will learn now in the next slide. Before we go for the study of turbines, there is one term which we need to know, nozzle. So generally we discussed that we are using water as an working fluid for the generation of energy. But if this water is flowing in a straight pipe, then we know that directly you cannot generate energy. So for example, if this is a pipe here, if you're observing carefully, this is a pipe with a uniform cross section. Whatever the fluid is entering at this point, whatever the fluid is entering at this point, it is example at this point that I will explain you. Yes. So at this point, whatever the water is entering, say it is entering at a speed of 50 meters per second. Now at this segment is coming out, it is having the same velocity itself, 50 meters per second. But if I want to develop energy, more speed of the water is to be required. So if the water speed has to be increased, then you have to change its cross section area. At that time, what we are doing here generally is we are taking help of a device known as nozzle. Let us see how we are using this device. So I was telling you that there is a pipe initially at this end, say it is its cross section area here. Then suddenly what I will do is I will go on changing its cross section area. See here, this is how I am changing its cross section area using a device known as nozzle. So if you observe this particular point, here you can see here initially yes, 1 minute. So you can see here initially the water enters through this section at a speed of say 50 meters per second. It flows through a uniform pipe whose diameter is say around 20 mm. 20 mm diameter is there, 50 mm, 50 meters per second speed is there. By the time when it enters this particular device, that is a nozzle, you can see its cross-section area goes on reducing. So by the end, if you observe here, its diameter reduced to completely half, say around 10 mm. Then what happens to the speed of the outlet water? It suddenly increases. So in other words, what you can say that nozzle is a device which is used mainly for increasing the velocity of a water, which means when the velocity of the water increases, then its striking force also increases. That is the reason that we are using this device known as nozzle only to increase the velocity of the incoming water itself. That is the purpose of using this device, that is the nozzle. Now, coming back to our point here, I was discussing that we generally use a device known as nozzle. In very simple words, nozzle is a device of varying cross section area. You can see the cross section area, inlet cross section area, you can see it is larger diameter, larger cross section area. At certain length, when it is coming to the outer side, you can see the cross section area is again reduced, which means whatever the water inlet speed is there, by the time it reaches to the outlet, its speed is increased. Only the principle to see that the kinetic energy of the incoming water has to be increased before it strikes the turbine blades. If it increases, then what happens? We can generate large amount of energy. That is the reason that we are making use of this device known as nozzle. Now, let's come to the first water turbine known as a Pelton Wheel turbine. If you observe carefully in this sketch, you can see here that this is a photographic view regarding the buckets which are installed on a Pelton Wheel turbine. The working procedure I have shown here in the side sketch. If you observe here, this is a pipe through which the water is taken from the dam. Generally, this type of turbine we are preferring only when the water available head is more than 300 meters. Keep this in mind. The water available head should be more than 300 meters. So the water which is taken from the dam, it is taken through a pipe known as penstock. The penstock, it is connected and it is passed to the turbine parts. So here in the Pelton wheel, the different parts which you can see here is, these are the hemispherical shaped buckets. We call them as buckets. These buckets, they are mounted on a circular wheel. We call it as a runner. Then the water which is coming through this penstock, it is passing through a nozzle, which you can see here at this part here. There is a nozzle, and this opening and closing of this nozzle, it is controlled by one spear head. This you can see, this is a spear. So this forward and backward movement of this spear, it controls the opening and closing of this nozzle. How it is done? With the help of a spear rod, which you can see rotated by the means of an hand wheel. And when the water is striking with great intensity here, there are chances that some amount of matter may be splashed. So to prevent that, it is covered entirely with a casing, that is a covering, to see that after the striking, the water can be collected directly in the tail race level itself. Now the working procedure. When the water is taken from the dam, it passes through a penstock. As it is passing through the penstock, already the potential energy of the water which is present in the dam is now converted into kinetic energy as it flows through the penstock. There is a sudden deviation. As the water is approaching towards this nozzle part, whatever the kinetic energy was there in that water, again that kinetic energy is increased when it approaches towards the nozzle, and with higher kinetic energy, with a greater amount of force, that is known as impulse force, it strikes on these buckets. And as it strikes on these buckets, they start to move upward, which are coupled to a runner, and this runner coupled to a shaft at the center, which also rotate to develop useful energy. Here in the tangential, here the water flow of this turbine, how it is occurring. See, this is nothing but a circle itself, which already has shown dotted form, known as pitch circle. Here the water which is coming, it is meeting in the form of an tangent. Therefore, this turbine, Pelton wheel turbine, we call it as tangential impulse turbine or a impulse tangential flow turbine. So water after striking the buckets, it causes the buckets to move upwards, and then the remaining water is discharged in the tail race. It is discharged in the tail race. Okay, and it can be used for other applications. This is regarding the Pelton turbine. Now, Francis turbine. This Francis turbine which you are observing in the sketch, generally we are using this Francis turbine when the water available head is in the range of 50 meters to 150 meters. I repeat, when the water available head is in the range of 50 meters to 150 meters. Now, when we are using the second turbine, that is the Francis turbine, keep this in mind. Almost in all the textbooks, he has given two types of sketches. One is the front view, another one is the top view. But if you want to understand the clear working picture, you need to draw the top view in the examination, which already I have shown here on the PPT. You can see here, this is the top view. This is the top view. So what happens? It's photographic view I have shown you here regarding how the blades are working seen here in this Francis turbine. Now let us go through the parts of the Francis turbine. This is the penstock pipe itself, which I have already told you, which is generally used for supplying the water from the dam towards the turbine. Then you can see these blades. You can see the first ring of blades, outer first ring of blades, we call them as guide vanes. Then the second ring of blades which you are seeing here, these are nothing but the runner blades. At the center, this is the shaft, and all these things which you are seeing here, which is covered in type of a casing known as a spiral casing. Now, here in this turbine, when the water is coming from the dam at an altitude in the range of 50 meters to 150 meters, it is having less kinetic energy. The potential energy when it is converted to kinetic energy, it is comparatively less kinetic energy when compared to the Pelton wheel turbine. So with that less kinetic energy, we cannot develop more amount of useful work. So what we do here, we are taking that water, and that water, it is passed through a spiral casing. If you see here the spiral casing, you see here, observe here carefully, the spiral casing, it is designed in such a fashion that when the water enters from this end, it is uniformly distributed throughout the entire radii. You can see here there are arrow marks, which means the water is entering uniformly, radially. We call it as radially, which means equal amount of water is entering through all the sides. That is the reason the name given for this casing is spiral casing. You can see the cross section area of this casing. Here you can see it is decreased and it goes on increasing. Why? To see that equal amount of water enters from all the sides. So here in this kind of turbine, we don't have here nozzle. But what happens here is we are having a set of fixed blades. We call them as guide vanes. You can see these are the fixed blades, guide vanes. And if you can see the design, how it is there in the form of curved shaped structures. So what it means, when there is a sudden deviation for this water entering from the dams through the penstock, there is a still increase in the kinetic energy of the incoming water. So what you can say that part of kinetic energy is developed, is used to strike through this guide vanes, and then it enters through the next set of blades known as the runner blades, which you can see here. The second part, this is inner circular. You can see this black arrow mark which he has shown. This is the runner blades. In the previous Pelton wheel turbine, I was telling you that to increase the kinetic energy, we are taking help of a device known as nozzle. But here we don't have nozzle. Instead of that, if you observe carefully the runner blades, if you observe the runner blades carefully, see here, this entire view, if you see here, the cross section area starting from this end. As I move on to the other end, what happens? It is goes on increasing, which means the blade designs and the mountings of the blades they have made in such a fashion that these blades itself act as a nozzle. And another part of kinetic energy, that is in the form of pressure energy, it is developed as the water passes through these runner blades, which is nothing but when they hit with great intensity on these runner blades, some amount of action reaction force is developed. That is, both impulse and reaction forces are developed, which causes these runner blades to rotate, which are mounted at the center shaft, causing the shaft to rotate, and useful energy is developed. After developing the work, this water, it moves out axially, it is discharged axially through this center shaft into the draft tube. That is the reason that Francis turbine, we call it as a mixed flow reaction turbine. Here the water enters radially through the guide blades, through the runner blades, and then it is discharged axially through the draft tube. Normally it is used when the water availability is in the range of 50 meters to 150 meters. Okay, friends. Then last turbine, that is the Kaplan turbine. So here also it is also a turbine itself, but the problem here is you cannot use for the heads above than 50 meters. In short, when the water available head is less than 50 meters, then only we can prefer this turbine, that is the Kaplan turbine. Here also, if you observe, this is the front view of this turbine. If you observe carefully, this is the scroll casing itself, which is a type of a scroll casing here. Then there is a center shaft. On this center shaft, that is a hub. Here you can see these parts. This is one part. This is another part. Two blades are mounted here, and these are the guide vanes. These are the fixed blades here. These are the fixed blades. These are the moving blades which are mounted directly towards the rotating shaft, and this is the bent draft tube where the water is discharged in the tail race. So here also somewhat like the Francis turbine, only thing is here the water in the Kaplan turbine, the water passes through the scroll casing. After passing through the scroll casing, it passes through the guide vanes, and from the guide vanes until it passes through the guide vanes, here it is in the radial direction itself. But after passing through the guide vanes, when it strikes the runner blades, you can see here the runner blades, what happens to the direction of water? It is nothing but the axial direction of the shaft itself. That is the reason that we call for this turbine, Kaplan turbine, water on the runner blades, how it is acting, it is striking in the axial direction itself. Therefore, for a Kaplan turbine, water strikes on the blades in the axial direction and is discharged in the axial direction itself. Only the phenomena here is it is also having a scroll casing where the water enters equally, that is radially through the casing through the guide vanes, and then after striking, it strikes to the runner blades in the axial direction and is discharged in the axial direction itself. Okay, this is the working of the Kaplan turbine. Thank you, students.